Now in this video we're going to start talking about our regular polygons. Regular polygons. Now we've discussed regular polygons before, and we know what regular means. All sides are equal and all angles are equal. Okay? The regular polygons before, we found how to, we determined how to construct the regular polygons by taking a segment like CD and rotating it. And of course, in our particular case, previously, we rotated a segment CD, 108 degrees around, point D. We also have a rotation that's called the central angle. And that central angle is the angle measured relative to this point in the center. That's the central angle here is 72. So one way which we could construct this, if we could just construct one of these segments, I should have referred to, let's refer to this point P in the center. PC, if I rotate that through 72 degrees, then that would give me the segment PD. Another 72 would give me segment PE. So the central angle is quite simple. It's simply the angle of rotation that would generate this figure for you. So in this case, the central angle is always going to be 360 divided by the number of sides. So 360 divided by 5 is 72. So rotation of segment PC, 72, would give you CD. Complete that rotation until you have all the segments and then connect it to form the polygon. Now, that polygon then, has a circle which circumscribes it. That circle is of radius PD. So the radius of the polygon is what we call the radius of the circumscribed circle. The radius of the polygon, I know we only think of radiuses as belonging to circles, but the radius of the polygon is the radius of the circumscribed circle, which here, of course, is going to be PB or PA or PE or PD. So they are the radii of the polygon, which are synonymous with the radii of the radius of the circumscribed circle. Now, there's also the inscribed circle. The inscribed circle, is as we see here, and the radius of the inscribed circle, the radius of the inscribed circle is known as the apothem of the polygon. The apothem of the polygon. So the apothem is drawn from the center of the polygon to the midpoint of each side of the polygon. That's the apothem. The green segment there is the apothem. Apothem. Some people say apothem or apothem. So going back, the radii of the polygon is the radius of the circumscribed circle. The radius of the inscribed circle is the apothem. And that's what we're going to have to look at when we're going to want to try to come up with a formula for creating the area of the polygon. So regular hexagon, central angle is going to be 360 divided by 6, which is going to be 60 degrees. So then each segment PE is rotated about the center point 60 degrees to form a regular pentagon. A regular pentagon, or hexagon, excuse me, which if these angles are 60, and of course PE and PD are of equal lengths, which makes these triangles all equilateral. What are three central angles? Well, there's 6 of them, right? EPD, DPC, so on and so forth. What is the perimeter of this polygon? Well, if AB is said to be 8, then there's 6 sides, so the perimeter is 48. Now, find the area of this triangle shown in in yellow, okay, which is essentially 1/6 of the polygon, is it not? It's 1/6 of the polygon. But we're not going to find the area of the polygon. We want to find the area of the triangle. And the triangle is 1/2 the height times the base. Well, the base is the segment AB, which of course is one side of the polygon. The height, well, what's the height? Okay, what's the height? Here's the height. The height is the apothem. The apothem. The apothem is again what? The apothem is, okay, is the radius of the inscribed circle. And that radius of the inscribed circle, again, is simply the segment drawn from the center of the polygon to the midpoint of the side. Okay? The apothem of the polygon is the height of our triangle. Okay? So PT is the height of the triangle that we're after. PD is also the apothem of the polygon, as we had said. PT is the radius of the inscribed circle, all synonymous. This segment PT has three different purposes. PT is the height of the yellow triangle. PT is the radius of the inscribed circle. PT is the apothem of the polygon. Okay? And what is the length of PT? Well, we agreed earlier that triangle ABP is equilateral. So let's look at it from that perspective. Here we go. We pull that triangle out. Okay? We knew that AB was equal to 8. We also knew that angle APB was equal to 60 degrees. All right? We also know that PA and PB are radii of the circumscribed circle, and that angles A and B are equal, which, as we said earlier, makes this triangle equilateral. So I'm going to take a look at the half triangle here, and we should agree that that half triangle is a 30, 60, 90. Okay? So we should then therefore agree that the measure of angle APT is 30 degrees. Okay? We know the length of AT is half the length of one of the sides, so that's 4. Okay? PT is the hypotenuse of the 30, 60, 90, which is twice the length of, okay, the short side. So that's going to be, I'm sorry, twice the length of the short side is PA. PT is 4√3 from the 30, 60, 90, okay? So here we go. We put it all together, okay? The area, again, we're after the area of that triangle PAB, okay? And we have all the pieces that we need. The area of the triangle is half the height times the base. The height was the segment PT, which we found was 4√3. The base was 8, okay? And so half that product is 16√3, all right? 16√3. So what if I were to ask you to find the area of the entire hexagon? Well, the area of the entire hexagon, of course, would be 6 times the area of just this one triangle, okay? Which would mean it would be 96 to root of 3. 96 to root of 3, okay? So we're going to examine finding the area of this polygon in a different fashion. So we'll actually come and do that in the next video. Okay, we'll call it quits on this one and come and resume with that in the next video.